Hey, greetings from Seattle. This is Bill Pan. I wish I could be there in Portland with you, but I trust you're having a productive conference. Now, the 4 million hectare REACH region is nearly a monoculture crop region with 60% wheat and 30% fallow. Crop system diversification research is evaluating the potential for increased legume and oilseed production, while crop intensification research explores the potential for fallow replacement with crops where feasible, growing more crops over the fall and winter months with winter varieties, and phasing out some of our CRP lands with better conservation farming techniques. We believe we will make great advances in all aspects of cropping systems research if we broaden our perspective from that of a focus on single crops to a more of a broader perspective on crop rotational sequences as a whole. And this applies to all transdisciplinary aspects of agronomic management, nutrient cycling, crop modeling, pest dynamics, economics, policy setting, and social acceptance. Now recall the Google Earth tour I took you on last year to all the cropping systems field experimental sites across the REACH region. And at each research site, the core Objective 3 team, along with the modeling and monitoring teams, are particularly interested in carbon, nitrogen, and water cycling and flow dynamics through these cropping sequences. We're really interested in knowing what changes in inputs, outputs, aqueous, and gaseous losses occur with the introduction of new crops into the rotation. Expansion of legume production further diversifies our regional marketing opportunities while reducing fertilizer nitrogen inputs of the rotation by fixing atmospheric nitrogen and by utilizing residual soil nitrogen. They are valuable crop commodities, particularly garbanzos. Recently, we're seeing fast adoption in the higher rainfall zone. Now, a key question for our team is how far can we push legumes westward into the drier regions? And in cropping systems research and producer trials, we're seeing legumes gaining ground in the transitional rainfall zones of 14 to 17 inches of rainfall from Pendleton to Ritzville to Davenport. Right now, there are very exciting prospects for expansion of regional oilseed production, primarily canola and perhaps camelina in the future. This has prospects for not only diversifying our agronomic and pest management, but changing our production economics and domestic end uses, stimulating local value-added industries. Our research has shown it will also change the carbon and nitrogen cycling dynamics for the better by returning more and higher quality straw and scavenging more soil nitrate. Now, key research questions remaining. Where do winter and spring oilseeds best fit? Grower case studies and research are revealing that winter canola is starting to challenge winter wheat in some of our traditional wheat fallow regions, while spring oilseeds are being shown to be able to replace fallow in the transitional zones, particularly in wetter years, and spring oilseeds are also starting to economically challenge spring wheat and spring peas in the higher rainfall zone. Principles revealed by basic plant and soil studies and applied field trials changes our views on best management practices that are delivered and debated with stakeholders, and these ultimately can affect policy and change in practices. For example, 5 years ago, a common understanding of canola management was, well, fertilize it like wheat. Now we know that we will need to change our nitrogen fertility recommendations for the industry's 4 R's concerning canola and alter our recommendations for fertilizer rate, timing, placement, and source. Recent EPA life cycle analysis has ruled that there will be overall a 50% reduction in greenhouse gas emissions in the U.S. on a BTU basis, replacing conventional diesel with canola-based biodiesel. The bar graphs show this reduction is mainly attributable to reduction in tailpipe emissions of prehistoric carbon. Now, savings could be higher, but canola based biodiesel is debited for its potential impacts on indirect land use displacement of food production and for carbon burning during fertilizer production, as well as soil N2O emissions during canola production. Now, in the upper right-hand graph, we are speculating that the inland Pacific Northwest could have greater greenhouse gas reductions than the national average due to lower fertilizer requirements, a rotational wheat yield increase that we're often seeing, and displacement of fallow in some situations, which will not incur the indirect land use charge. What's the possible time frame for real change in cropping systems? Well, here are some examples of canola adaptation in other semi-arid regions of the world similar to ours, with major increases occurring within a decade. And we've seen a similar increase in garbanzo production over the last 5 years in the Pacific Northwest. And just over the last 3 years, we have seen a doubling of canola acreage in the inland Pacific Northwest, with the moon aligning with the stars on a number of fronts listed in the blue box. Now, we may be at the next leading edge of a global increase in canola production, and REACH efforts will help move us in that direction. The successful adaptation of alternative cropping systems requires the efforts from all stakeholders to optimize these new systems that will be adaptive not only to shifts in climate, but also to changes in global and production economics, pest biology, and societal demand for crops and environmental services. Ergo, the need for transdisciplinary research and stakeholder integration to model, test, revise, and commercialize these new systems. That's it for my 7 minutes. I will see you all this summer when I get back from Seattle. Take care.